Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Lecture for grade 10, subject chemistry, chapter number 12, lecture number 18, and here is your lecturer, Mrs. Saira Jamal. Dear students, as you know that this chapter is about hydrocarbons. In the previous lecture, we discussed about the alkanes, and today I'm going to talk about the second class of hydrocarbon, that is the unsaturated hydrocarbons, and the type of unsaturated hydrocarbons are alkenes and alkyne. First of all, we will discuss alkenes. What are alkenes? Alkenes have one or more double bonds between carbon atoms. It means that those unsaturated hydrocarbons which contain at least one carbon-carbon double bond are called alkenes. What is the general formula of alkene? The general formula of alkene is CnH2n, and there is no plus 2. In case of alkane, the general formula was CnH2n plus 2. But due to the carbon-carbon double bond, alkenes are 2 hydrogen atom less than alkanes. So there is no plus 2 in this case. General formula for alkenes are CnH2n. When two carbon atoms share two electron pairs, you know that they form double covalent bond or double bond between the carbon atoms. How many electrons are left on each carbon atom? Doubly bonded carbon atoms form single bond with two other atoms. Now you can see in this case, you know that 4 electrons are present in the outermost shell of carbon. So carbon will make 4 bonds. Now 2 bonds this carbon make with this carbon atom, and the remaining 2 bonds, 2 single bonds, this carbon will make with 2 hydrogen atoms. So in this case, 2 or double covalent bond is present between the 2 carbon atoms, and 2 single covalent bonds each carbon will make with 2 hydrogen atoms. So a total number of covalent bonds made by each carbon atom. In this case, this carbon atom made 1, 2, 3, and 4 bonds. Same is for this carbon atom, 1, 2, 3, 4. 4 bonds of this carbon atoms are present. In example of alkene, 2 carbon containing alkene, that is ethene. So ethene, like this is the formula of ethene, which contain 2 carbon atoms, and at least 1 double bond is compulsory for alkenes. Now the second example of alkene is propene. Pro for 3 carbon atoms, and ene, like at least one of the carbon-carbon bond, it is double bond. So you can see 1, 2, 3, 3 carbon atoms, and one of the bond is double bond, the rest are single. But I told you that at least the presence of one double bond is compulsory. So the name of this compound is propene. Pro for 3 carbon containing hydrocarbon. Example 12.3. Draw structural formulas for 1-butene and 2-butene. It means that the position of the double bonded carbon atom will be different. In 1-butene, the double bond will be present at carbon number 1, and in 2-butene, the double bond will be present at carbon number 2. How to draw the structure formula? It's very easy. But means for 4 carbon atoms, and ending "ene", ene means that it indicates that it is an unsaturated hydrocarbon which contains carbon-carbon double bond, and it is called alkene. Write a string of 4 carbon atom and assign number to each carbon atom from one side. We have to label the carbon atoms like carbon number 1, 2, 3, and 4. Number written before the name indicates the position of double bonds. Make a double bond between indicated carbon atom and the atom next to it. Although enough hydrogen atoms to the carbon atoms to give each carbon atom 4 bonds, we have to add the hydrogen atoms like to complete the 4 bonds of each carbon atom. Let us see in this case, as I told you that first of all we have to write the string of 4 carbon atoms, then we have to number the carbon atoms 1, 2, 3, 4, and as in case of 1 butene, I told you the double bond must be at carbon number 1, starting from carbon number 1 and between the next carbon atom, which is 2. So we will make double bond between carbon number 1 and 2, but the starting point must be 1 because it is 1 butene. So 1 butene, and then we have to complete 4 bonds or valency of each carbon atom by putting or by adding hydrogen atoms to the by attaching hydrogen atom to each carbon atom. This carbon atom has 2 bonds in front, and it means it needs 2 more bonds. So you can see we will attach 2 hydrogen atoms with this carbon number 1. Carbon number 2 has 2 bonds in you can say at the back side, and 1 bond is in front. So there are 2 and 1, 3 bonds. For the 4 bond, we will attach only 1 hydrogen atom. This third carbon has 1 bond at the back side and 1 in front. It means it needs 2 more bonds. So those 2 more bonds it will make with 2 more hydrogen atoms. And the last one, that is the carbon number 4, it has only 1 bond at the back, so need 3 more bonds. So those 3 bonds it will make with 3 hydrogen atoms. The same thing we will repeat for 2 butene. The difference between 1 butene and 2 butene is only in 1 butene the double bond is present at carbon number 1, and in 2 butene you can see double bond is present at carbon number 2 and the carbon which is next to carbon number 2, that is carbon number 3. We will do the same. We will complete the 4 bonds of each carbon atom by attaching hydrogen atom with each carbon atom. So these are the structure formulas of 1 butene and 2 butene. Self-assessment exercise 12.5 and 12.6 are same like these questions. So it is your assignment. Then coming towards the, we have next topic, that is general methods of preparation of alkenes. How can we prepare alkenes? Like as you know that we discussed in the previous lecture how to prepare alkanes, and we discussed 2 important methods. And now in this case we are going to discuss the general methods of preparation of alkenes. There are 2 important methods for the preparation of alkenes. The first one is by dehydration of alcohols, and the second method is by dehydrohalogenation of alkyl halides. We will discuss these methods one by one. Let us discuss the first method, which is by dehydration of alcohols. Dehydration means loss of water, and alcohols dehydrate when their vapors are passed over heated alumina. It means in the presence of alumina, and by heating it, alumina is heated, hot state, what will happen? The water, like the OH group from the alcohol and hydrogen from the another carbon atom, will evaporate out in the form of like vapors. So you can see in this reaction, alcohol, you know that those hydrocarbons which contain this OH functional group is called alcohol, or ROH. This is R, all these groups are R, alkyl group, and this is OH attached with the alkyl group. ROH is the functional group or the general formula of alcohol. So this is an example of alcohol. How many carbon containing alcohol? 2 carbon containing alcohol. So for 2 carbon atom, we will use ethane, and the E of ethane is replaced by ol. So ethane, from ethane it is ethanol. Only instead of E of ethane, we will use the these two letters ol. So this become ethanol. Ethanol in the presence of alumina, Al2O3, aluminium oxide. It is also called alumina, and definitely we have to heat it at 340 to 450 degrees centigrade. What will happen? OH from this carbon atom and hydrogen from the neighboring carbon atom will evolve out in the form of water. And these 2 carbon atoms in turn will then make 2 double bonds, or sorry, you can say a double bond. So in this case, you can see it has 2 hydrogen atoms and 1 hydroxyl, while this carbon has 3 hydrogen atoms attached with it. But hydrogen from this carbon atom and hydroxyl from the side carbon atom will evolve out in the form of water. and the bonds of these carbon will not be balanced. Then in order to stabilize their valency, in order to have 4 bonds, these 2 carbon atoms will make 4 bonds with each other. Phosphoric acid and phosphorus pentaoxide can also be used as a catalyst for dehydration of alcohol. Like in addition to alumina, we can also use some other dehydrating agents as well. Like we can use phosphoric acid, we can use phosphorus pentaoxide, can also be used as a catalyst for dehydration of alcohol. And also we can use concentrated sulfuric acid. So we can use alumina, phosphoric acid 2, phosphorus pentaoxide 3, concentrated sulfuric acid 4. All these 4 compounds we can use as a dehydrating agent for this process. Now we have one more example, that is you can see the same ethanol, because there are 2 carbon containing alcohol, ethanol, and if we use concentrated sulfuric acid as a dehydrating agent instead of the alumina, you can see the temperature is, in this case, is lower, 140 to 170 degrees centigrade, and it can give us the same product, alkene, that is ethene, and water. Dehydration of ethanol will give us alkene and water, even in the presence of concentrated sulfuric acid, but temperature is less from the previous case. Note, in dehydration reaction, OH group is removed from one carbon atom and hydrogen from adjacent carbon atom. Adjacent means the neighboring carbon atom. Don't remove hydroxyl group and hydrogen from the same carbon atom. That will be wrong. For dehydration, it is compulsory that hydroxyl group from one carbon atom and hydrogen from the side carbon atom or the adjacent carbon atom will remove. 2 such carbon atoms form double bond, and such a reaction is called elimination reaction, because water is eliminated, like OH group from one carbon atom and hydrogen from the second carbon atom are eliminated or are removing. That's why these type of reactions are called elimination reaction. Which alkene is formed by the dehydration of propanol? If you will use propanol, like the 3 carbon containing alcohol, then which type of alkene will form? You can see 1, 2, 3 carbon containing alcohol, because OH group is present there, which is the functional group of alcohol. And after dehydration of this alcohol, that is the propanol, will give us the product propene. Like you can see, these 2 groups are, this group is same, but hydrogen from this carbon atom and hydroxyl from this carbon atom. OH from carbon number 1 and hydrogen from carbon number 2 are eliminated in the form of water, and these 2 carbon atoms will then in turn form double bond, and this reaction will take place again in the same thing in the presence of alumina or concentrated sulfuric acid or phosphorus pentaoxide or phosphoric acid. Any of those dehydrating agent at high temperature can give us these alkenes. That is propene. From propanol, propene will form. From ethanol, ethene will form. From butanol, butene will form. Second method of preparation of alkene is dehydrohalogenation. Dehydrohalogenation, as from the name indicated, that it means that dehydrohalogenation. Dehydro means removal of hydrogen. Halogenation means halogen group. So this means loss of hydrogen halide. It means hydrogen from one carbon atom, and halide ion means the any element from the group number 7 which has a negative charge, like fluoride, chloride, bromide, iodide. They will remove from the second carbon atom, and then in turn, same like in the previous case, the 2 carbon atoms will form double bond after the elimination of hydrogen from one carbon atom and halide group from the second carbon atom. So hydrogen from one carbon atom and halogen from another carbon atom on heating with alcoholic potassium hydroxide undergo dehydrohalogenation. In this case, presence of alcoholic potassium hydroxide is compulsory. You can see that this is an example of that is the, you can say, alkyl halide. Alkyl halide, this is alkyl group, and instead of OH, which was in case of alcohol, bromine is attached here. So alkyl, and this is bromide. Alkyl bromide, or you can also call it ethyl bromide, because two carbon containing group, and alkyl radical is called ethyl bromide. Also, it is called bromoethane. Bromoethane, ethyl bromide, both are the correct names. So you can see that hydrogen from one carbon atom and bromine from the second carbon atoms, they are eliminated in the form of, you can say, actually they are eliminated in the form of HBr, but that HBr then react with this potassium hydroxide K with bromine will give KBr, potassium bromide, and OH with hydrogen will react and will form water. So the final products will be ethene, potassium bromide, and water. Actually, these alcoholic potassium hydroxide help in the elimination of this hydrogen bromide from the alkyl halide, and the product form will be ethene, because after the elimination of these two groups, then carbon will have 1, 2, only 3 bonds. Valency of carbon will not be satisfied, so in order to complete its valency, the two carbon atoms will form double bond. Next topic is about the properties of alkenes. As I told you, we have two types of properties, physical properties and chemical properties. So the physical properties of alkenes are unsaturated hydrocarbons. First three members like ethene, which contain 2 carbon atoms, propene 3 carbon atoms, butene 4 carbon atoms, they are gases. And then those compounds which have carbon number greater than 4, like from 5 till 15, they are liquid. And then those compounds which contain carbon number greater than 15, like from 16 till infinity, they are solid. And again, they are, I told you that organic compounds are non-polar in nature, so they are insoluble in water, but they are soluble in organic solvents like alcohol, because alcohol, like the higher chain alcohol, I told you, are non-polar in nature. They have means greater property of non-polarity. So they are soluble in organic solvents such as alcohol. The 2 carbon atoms forming double bond are joined to only 3 atoms, since a carbon atom can join to 4 atoms. So other molecules can attack at this site of double bond. A molecule which will attack, it will attack at the double bonded carbon atom, because the double bonded carbon atom, one bond is sigma bond, another is pi bond, and pi bond is a weak bond. So any molecule, if attack on this alkene, they will attack at a double bonded site. Now, chemical properties of alkenes. Reaction, first property is reaction with halogens. You know, halogens, chlorine and bromine, they add to the double bond. One chlorine atom becomes attached with one carbon and the other with other carbon atom. We have 2 chlorine, like we have a chlorine molecule which contain 2 chlorine atoms. So one chlorine atom, after breaking this double bond, will attach with one carbon atom, and second chlorine with the second carbon atom, and then in turn you can see it will give us dichloroethane, because it has 2 chlorine atoms, so we will call it dichloro, and 2 carbon atoms, so eth, and single bond is there in dichloroethane, because all the bonds are like the carbon-carbon bond is a single bond. This test or this reaction which I told you or I explained before, that is, we can use it as a test for unsaturation. Like if in lab a solution is provided to you and asked you to identify that either the given solution is of saturated hydrocarbon or unsaturated hydrocarbon. So for this purpose, for the identification of unsaturation of a hydrocarbon, we can use this test, which I already explained, and that is called the bromine water test because we are using bromine. It is also called bromine water test or bromination. Halogenation reactions are called addition reaction. If you remember in the preparation of alkenes, I told you the reactions over there where alkenes are prepared from that is alkyl halide and from alcohol, elimination takes place. The two groups are eliminated from two carbon atoms. But in this case, you saw it that the addition of the two atoms takes place on the carbon atom. So these type of reaction where the atoms are added to the hydrocarbons are called the addition reactions. So bromine is a reddish brown liquid and the product is colorless. If we add bromine water, which is reddish brown in color, in the test solution or in the given solution and shake it and then check the color, what happened, we will see that the color of the bromine, which was reddish brown, become colorless or it will turn colorless. The colorless or the like you can say the color change from reddish brown to colorless, this change show that the given solution is unsaturated hydrocarbon. And if nothing will happen to the color of bromine after adding in a test solution, it means that the given solution is a saturated hydrocarbon solution, not an unsaturated solution, because alkynes which contain carbon-carbon triple bond, they also gave the same result because they are unsaturated hydrocarbon. Alkene and alkyne both are unsaturated hydrocarbons, and then they decolorize the bromine, and this confirms that the given solution is of unsaturated hydrocarbon, either alkene or alkyne. And the same thing will happen. The bromine will, same like chlorine, the two bromines will, one bromine will add at one carbon atom and second bromine will add up at the second carbon atom. And we will call it dihalide. Di means two, halide means halogen groups, halogen elements or halide elements. So it is called dihalide. We can also call it dibromide, or it is also called dibromoethane. In bromine water test, when bromine is added to an alkene, the reddish brown color disappears. So this decolorization of bromine is frequently used as a simple test for the presence of unsaturation. And as I told you that alkynes also give this reaction because alkynes are also unsaturated hydrocarbons. Next chemical property of alkene is reaction with potassium permanganate, and this potassium permanganate test we also use it for the confirmation of, or for the identification of the unsaturated compounds, and this test is called Bayer's test. This reaction is called, or this test is called Bayer's test, bromine water test, and the Bayer test. Both tests we use for the for testing unsaturation in a compound. So what is Bayer test? In Bayer test, when an alkene is treated with dilute alkaline aqueous solution of potassium permanganate. Dilute, you know, alkaline means we will add a base in it. So by adding potassium permanganate in a base will make it alkaline solution. 1% means only, like you will add only 1% of the solution, and making 1% of the potassium permanganate solution, alkaline solution. Addition of, what will happen? Addition of two hydroxyl groups occurs across the double bond. You can see this is ethene and alkene reaction with potassium permanganate, and as it is dilute solution, definitely we will add water, which will make this potassium permanganate a dilute solution, and 1% dilute solution. What will happen? You can see the two hydroxyl groups will attach with each carbon atom. One hydroxyl group with one carbon atom, and second hydroxyl group with the second carbon atom. The pink color of potassium permanganate solution is discharged during the reaction. Same thing will happen as in the bromine water test, that the decolorization of the bromine water will take place. Same is over here, that the pink color of the potassium permanganate will discharge, or the potassium permanganate solution will decolorize when we will add it in the alkene solution. So this decolorization of the pink color of potassium permanganate confirm that the given solution is of unsaturated hydrocarbon. You can see the reaction that alkene, when react with the dilute solution of potassium permanganate, it will give ethylene glycol, which contain two hydroxyl group attached with each carbon atom. The side product forms are manganese dioxide and potassium hydroxide, which make the solution alkaline in nature. Where we use this ethylene glycol, or what is the importance of this ethylene glycol? Ethylene glycol is used as an anti-freezing agent in the automobiles engines. Next is about the uses of alkenes. What are the uses of alkenes? Alkenes occur widely in nature, and the ripening of fruits and vegetables give off ethene, which helps in further ripening. Like the fruit which ripen is due to the presence of ethene in them. That ethene will help in the ripening of fruits. So if you want to ripe the fruit artificially, or if you want to artificially, we use ethene to hasten the normal ripening process. For example, if we have 1 kilogram of tomatoes, and it can be ripened by exposure to only 0.1 milligrams of ethene for 24 hours. If you want to ripe the fruit vegetables in 24 hours, you will use only 0.1 milligram of ethene for that purpose. And those cartons, in those cartons, when it contains vegetables in it, and a small pack of ethylene glycol is placed over there, and that ethylene, so that ethene will help in the artificial ripening of those fruits and vegetables. Next, the red color of tomatoes is due to the presence of an alkene which is called lycopene. Lycopene is present in tomatoes, which give a red color to tomatoes. Dear students, self-assessment exercise 12.6 and 12.7 is your assignment. And I hope you understand this lecture. This lecture was all about the alkenes. As I told you that alkenes are called unsaturated hydrocarbons, and they have carbon-carbon double bond. And I told you the main important thing, that at least the presence of one double bond is compulsory. The rest of the bond, if they are single bond, so no problem, but at least the presence of one double bond is compulsory. And how can we prepare alkenes? I told you that alkenes are actually two hydrogen atom less than alkanes. The general formula for alkenes are CnH2n plus 2, while in this case the general formula for alkene is CnH2n, which is two hydrogen less than alkane. And each carbon contains 4 electron, because carbon belongs to group number 4 of the periodic table. And if the two carbon atom, they will form double bond, so it means that two bonds are in between the two carbon atom, and the rest of the two bonds, the carbon will form with two hydrogen atoms. You can see, if double bond is present between two carbon atom, then the rest of the two bond, because I told you each carbon atom will make 4 bond, so the rest of the two bond it will make with the two hydrogen atoms. Same for this carbon atom, one double bond between the carbon atoms, and the two single bonds are with the two hydrogen atoms. Now, inshallah, in the next lecture, we will discuss alkynes. And till then, Take care. Allah.